So the trapezoidal approximation. There are other approximation methods, but this is the only other one we're responsible for besides RAM. So another option for estimating the value of an integral instead of the RAM method is the trapezoidal rule. I think it might be helpful if you just wait to write down the formula until after I've shown you where it comes from. So I'm going to draw, you might want to do this, go ahead and draw an XY grid and draw a little curvy continuous function. And I'm just going to go ahead and look at the first quadrant portion of this and go from positive A to B. So that, let's just close it off there. And we are going to create trapezoids. You got to remember the trapezoids, they're going to be on their sides. The trapezoids that are kind of turned. And they would look like this. If I were to put a dot, say right, black, so a dot right here and then a dot right here, and then draw straight down and straight over there. I create a little trapezoid. And so you got to turn your head here. The height of the trapezoid is this piece. Do you guys see that? So the height is this piece, right over here. That's the height. So we're and then base 1 would be this piece, and base 2 would be this piece, where the area of a trapezoid is equal to 1/2 the height times base 1 plus base 2, or as it's written here, area equals h over 2 base 1 plus base 2. And then the next trapezoid, if I were to put a dot here and a dot here, it shares, or base 1 of trapezoid 2 shares base 2 of the first trapezoid. So if you notice here, I went ahead and colored over the bottom base of the first trapezoid, and so these two share the base. And then I've drawn my other base here. And then if I go ahead and make another trapezoid, all the way over to here, you'll see that once again, they share a base. And then I'll do my final trapezoid here. And there it is. So that's made up, that interval from A to B is made up of 4 trapezoids. I would find their areas and add them up. Now, if the intervals down here are the same, this formula will work just fine. I have seen in the AP free response them give you just a table of values. And so you're calculating the area of maybe 3 or 4 individual trapezoids that don't have the same height. Okay. But here's how the formula works. Trapezoidal rule says the integral is equal to t, which is equal to h over 2. And the height of the trapezoids, if they are all the same, can be found by calculating the length of the interval, b minus a, divided by the number of subintervals. Why not? Because base 1 of this trapezoid is only used once, plus 2 times y sub 1. The reason this is being doubled is because base 2 of the first trapezoid is also base 1 of the second one. And that happens all the way through until you get to the other end. Does that make sense, that how the formula works? So this is a trapezoidal formula. I don't know if I necessarily would memorize the trapezoidal formula, but just understand the method of using trapezoids to estimate the integral. So y sub n would be, in this case, we'd have y sub 4. This would be y0, y1, y2, y3, y4. And so everything but y0 and y4 would be doubled. And then I think I may have told you MRAM was the average of the other two. That's not true. But it is true that this is the average of LRAM and RRAM. Okay. MRAM is actually different. It would be the average if it were a linear function. But the trapezoidal rule, why is this the average of LRAM and RRAM? Well, think about it. For LRAM, I would start by using the left endpoint of the first subinterval, right? So I'd plug in A here. and y naught is the height of the rectangle that goes with A. So I would add y naught all the way through to here, not including y sub n. And then RAM would start here with y sub 1 and go all the way through y sub n. And so I'd add those two together. That's where the doubling here is getting overlap from LRAM and RAM. I'd add all those together and divide by 2. So you can use your program to check your work by adding the values from LRAM and RAM and divide by 2. So let's do one example of an explicit function here. And then I'm going to use the AP free response that we did for homework for the other example. So it says use the trapezoidal rule to find the integral from 1 to 2 of 1 over x. So my picture would look like this. Here's 1, here's 2. At 1, the function is up at 1. At 2, it's at 1/2. So there's my function. And if I'm going to use the trapezoidal rule with n equal to 4, I'm going to be splitting this into 4 trapezoids. So this first interval would go from 1 to 1.25, and then 1.25 to 1.5, and 1.5 to 1.75, 1.75 to 2. So the values I'll be plugging in here in my table would be 1.25, or write it as 5/4. So we have 1 5/4, and then 6/4, or 3/2. I'll just write it as 6/4, and then 7/4, and then 8/4, or 2. So those are the values of x that I'm going to plug in to get my y naught, my y1, my y2, and so forth. So here you'll get your y naught. Y sub 1, y sub 2, y sub 3, y sub 4. So take 1 and plug it into the function here. You get 1. Take 5/4 and plug it in here. This is kind of like known as the reciprocal function. You get 4/5 that. And then what happens when I plug in 6/4? 6, or 2/3. And then this is 4/7, and this is 1/2. Now, the height h is equal to b minus a, which in this case is 2 minus 1, divided by 4, the number of subintervals, and so that's where the 1/4 comes in. The 1/4, remember, is the height right here. So 1/4 is this piece. This is a height of 1/4. This is a height of 1/4. This is a height of 1/4, and this is a height of 1/4. And in the book, our problems are like most of the problems I found in there were using explicit functions, and they were using trapezoids with all the same height. What I've seen in recent years is they've used tables, and the intervals between the x's have not been the same. So let's get rid of that. We'll have practiced that before the AP exam too. So I can use the formula directly here. We have 1/4 over 2. Y naught is 1 plus 2 times 4/5 plus 2 times 4/6 plus 2 times 4/7 plus 1/2. And that is the value, or the estimate, for the integral. So let's go ahead and find that. If you could find that quickly here. Okay, so the value of the integral from 1 to 2 of 1 over x dx is approximately equal to, by the trapezoidal rule, the following value: 0.695-ish. You should get about 0.695. Usually for the AP it's 3. That's a good question. There's actually, we'll talk about that when we start preparing for the AP exam. It's 3 decimal places, 3 to the thousandths place. Okay, was this going to be an under or an overestimate in this case? Under, yes. it will be an underestimate. Well, these are lines, and this is a curve. Well, actually, no, it's not going to be an underestimate. It looks like it from my picture. But that thing's concave up. It's not an underestimate. My trapezoidal rule will be a overestimate, yeah. 0.695. An overestimate. Let's just check that. Try it on your calculator using FNN. Do FNN of this integral and see what you get. I'm curious. Or, well, that's still an approximation method. Go ahead and use FNN and find out what it is. I think it ended up being, I don't remember now. It's tough to try it. But it will be an overestimate. 0.693. Okay. So 0.693. That's still an approximation method that your calculator is using, but it's a little more accurate than using 4 trapezoids. So, but not bad on this one, right? Look at this. Not bad. All right.